In this example, we're going to look at the limit as x goes to negative infinity of negative 3x to the fourth plus 3x squared plus 1. So this is the same function as in example 1, only this time instead of looking at the limit as x goes to positive infinity, we are going to look at the limit as x goes to negative infinity of this function. Okay, so basically we're going to proceed exactly as we did before there. So same situation, we're going to look and find the highest power of x, and we're going to factor it out. And then we're going to cancel any powers of x that we can inside the parentheses there. Okay, and going to write that function as power functions, or any functions in there as power functions when we can. So all these steps are exactly the same thing that we did before, right? And now we're going to analyze each of these pieces, right, and see what happens here. So inside the parentheses, nothing really is going to change much. The limit as x goes to negative infinity of negative 3 is going to be negative 3. The limit as x goes to negative infinity of 1 over x squared, right? Remember these power functions where the x2 is in the power of x is in the bottom, right? All of those go to 0 as x goes to infinity or minus infinity. So if you recall those facts about the power functions from the previous video. So this will go to 0. Same thing, right? This is 1 over x to the fourth. So all of those power functions, 1 over x to some positive real number power, they all go to 0 as x either goes to infinity or minus infinity. So all of that part right there is exactly the same. What about this x to the fourth? Well, if you recall, right, for these power functions, x to some whole number power like this, the behavior as x goes to negative infinity kind of depended on the fact on whether or not the exponent was even or odd. In this case, it's even, right? And so if I have a negative number raised to an even power, the result will be a positive. So also here, nothing changes, right? The limit as x goes to negative infinity of x to the fourth is positive infinity. So once more, I have that same situation here, okay? And I can do some simplifying. So in effect, the x to the fourth part goes off to infinity, right? And the stuff inside parentheses goes to negative 3. And so this part is becoming large, but then I'm multiplying it by a negative 3. So once again, that forces the limit as x goes to negative infinity to be negative infinity in this example. So here, nothing changed. Whether or not for a polynomial, whether it changes or not from one side to the other is really going to depend on the exponent. The highest power of x here was even, so it's really going to have the same behavior on both sides. When this is odd, right, then the behavior will change from one side to the other. In other words, the limit as x goes to infinity and the limit as x goes to negative infinity are going to be the opposites of each other.